Okay, we're going to start by talking about angles in circles, okay? Just as a review, an angle whose vertex is the center of a circle is a central angle, okay? Those sides of the angle are radii. And an inscribed angle is an angle whose vertex is on the circle, okay? And it can be any point on the circle. And those sides of the angle are chords. Okay, so here, this first little bit here, we are actually going to draw a central angle in. Okay, let's do it in green. Sure. Okay, so pick where you think the center should be. We'll call it point B. Okay, and remember, radii go from the center to any point on the circle. Okay, we'll name these points A and C. Okay, so angle ABC right here, this is the central angle. Okay, and a central angle, the measure, the number of degrees, is equal to the measure of its intercepted arc. Okay, in this case, the intercepted arc here is arc AC. Okay. So if I'm going to write that as a math sentence, the measure of angle ABC is equal to the measure of arc AC. Okay, so say if this was 105 degrees here, if angle B was 105 degrees, the measure of arc AC would also be 105 degrees. Okay. So example 1 here, what I like to do is I like to go ahead and trace those sides of the angle. Okay, so like here, 123 degrees, we can see the intercepted arc, that arc between the sides of the angles is what we're looking for. Since a central angle is equal to its intercepted arc, this is also 123 degrees. Okay, here, FE is the intercepted arc that we're looking for. And so if we follow those sides back, we need to find the measure of this angle first. Okay, now one thing that I notice, E to B goes through the center. That is our diameter. Okay, so we have 180 degrees to cover from E to F all the way to B. Okay, so if I take 180 minus the 135 that I already know right here, that's going to get me the measure of this central angle. Okay, which again, the central angle is equal to the intercepted arc. Okay, so the measure of that arc FE is 45 degrees. Okay. Number 3, we want the measure of angle MIJ. So from M to I to J, this is what we're looking for right here. Okay, so we're looking for a central angle, but again, we have an arc. We have 55 degrees, okay? MK is the diameter. It cuts this circle in half. So we've got 180 degrees out here, but we've already used 55. Okay. So this arc from M to J, that means there are 125 degrees left. Since the intercepted arc and the central angle are of equal measure, angle MIJ is also 125 degrees. Okay. inscribed angles, here, let's do it in green. Remember, the vertex is on the circle and the sides are chords. Okay, so we'll say this is QRS. This here is the inscribed angle. Okay, and its intercepted arc here is QS. The measure of the inscribed angle is half of the measure of its intercepted arc. Okay, so the measure of angle QRS is half of the measure of arc QS. Okay, so if QS is 150 degrees, we divide that by 2 to get 75 degrees here. Okay, or we can look at it as the measure of the arc is twice the measure of the inscribed angle. Okay, so again, we'll use the same numbers. If we know the measure of QRS is 75, we need to multiply by 2 to get that measure of 150 degrees for that arc, okay? So the measure of arc QS is 2 times the measure of the angle. Okay, here's some examples. All right. Here we're looking for the measure of the inscribed angle. Okay, follow its sides out to find that intercepted arc. Okay, I see it. The intercepted arc is 80 degrees. So to get the measure of the angle, I divide by 2. Okay, so our answer for this first one is 40 degrees. Here, WV is the arc that I'm looking for. If I follow those back, that takes me to angle X. Okay, if I know the inscribed angle to get to the measure of the arc, I need to multiply by 2. 42 times 2 is 84 degrees. Okay. Now, this last one here, I'm looking for an arc that doesn't have an inscribed angle attached to it. Okay. But I do have the measure of angle S here. Angle S, since S is on the circle, this is an inscribed angle. And to get to the measure of this arc, I need to multiply by 2. Okay, 95 times 2 is 190 degrees. 190 plus the additional 75, that is right here, gives me 265 degrees. Okay, there are 360 degrees in a circle altogether, so when I subtract 265, I get my final answer of 95 degrees. Okay. Couple more here. Okay. Any inscribed angle. So here's a vertex. We'll call this X. We'll make this W, Y, and we'll say the center is Z. Okay, any angle that is inscribed in a semicircle, okay, or that intercepted arc is a semicircle, okay. There's 180 degrees over here. To get back to the angle, remember we have to divide by 2, okay. 180 divided by 2 is 90. So any angle that is inscribed in a semicircle is a right angle. Okay. Now, this next one, say I've got this inscribed angle right here. We'll call it JKL. Okay, and then we have a second inscribed angle, but that inscribed angle also intercepts arc JL. We'll say JML. Okay. If we've got two inscribed angles here, that when you follow their sides out, they intercept that same arc, those are congruent. Okay, so angle JKL is congruent to angle JML because they both intercept arc JL. Okay, so we've got two examples here. Okay, first one, we are looking for the measure of angle PDF. Okay, so angle PDF here intercepts arc PF. Okay, see that this other angle that we're given, angle FEP, also intercepts that same arc. So since angle FEP is 35 degrees, angle PDF also has to be 35 degrees. Okay. Here I see X to V, that segment goes through the center. That means this is our diameter. So over here is a semicircle. Okay. Or half of the circle, 180 degrees. Okay, we're looking for the measure of angle XWV. Okay, since that angle intercepts the semicircle, it's a right angle, so its measure is 90 degrees.